Welcome to another episode of the Spatialedge AI show. Today with me I've got Tristan.
Hi.
And we are going to kick off with a little bit of a deep data discussion. So Tristan, some would say that data science is basically just statistics.
Okay.
Do you agree or disagree?
Okay. I agree.
Ooh.
Oh, difference of opinion.
Okay.
Right, so I'll elaborate a little bit about why I agree. I think most of the technical methods and tools and techniques used day-to-day in a data scientist's work life, basically all of these come from statistics, whether it's exploratory data analysis, you're working in your Jupyter notebook trying to understand your problem, or building a machine learning model. I think machine learning is very much an extension of statistics. Pretty much all forms of machine learning, they have their foundations in statistics. I think a lot of data science problems can be solved with basic statistics. I think a lot of people jump to complex, like cool transformers and neural networks and whatever in ML. But I think fundamentally the grounding, the fundamentals is statistics.
You have to start with statistics.
You have to start there. You have to have a solid background in statistics. But the reason I go for agree and not strongly agree is because there's a lot of other skills that you really need to be a strong, well-rounded, maybe sort of full stack or unicorn data scientist, right? Like you need to be able to program well. You need to be able to abstractly problem solve well. You need people skills because data science is very much a business-facing role. It's not like an engineer where you're sitting behind your laptop or your 100 monitors doing your thing, delivering value. You interact with people, domain experts, subject matter experts, people that know nothing about programming or tech or statistics or machine learning. These are business people. They know about banking or insurance or whatever domain they're working in. You have to sort of pull out of them through conversation and meetings about what actually do they need solved to create value for them, because in my experience, they don't know how to tell you that. They sort of know they have a problem. They sort of know what data they may have. Maybe they don't even. And they know that they want to use this sexy new tool and technique, data science or AI. But you really have to get out of them all the nuances of the problem and understand and make sure that you're delivering value for them at the end of the day. And that's why I think statistics super important, but programming, interpersonal skills, equally as important.
You actually now went down a very interesting route. So in the beginning, you completely sold me on the idea of it is just statistics.
Yeah, maybe.
But my mind when I went to the disagree option was that there's other skills. But then you actually went down that route as well.
Yeah.
Okay, but hold on. The underpinnings is statistics. But,
Yes.
I mean,
so
one could argue like programming is also in some way statistics. If you program statistical programs, you are using statistics.
Yeah.
So but there's other skills to it as well.
So which piece of that pie can you not do without when you're a data scientist, right? If you're a data scientist and you have bad interpersonal skills, I think it's a detriment to your personal career growth and capabilities. But you can still do it, you know? You can still be the silent individual lone warrior on the team doing good statistical work, doing good ML work, training great models, delivering value, sure. But if you don't have any stats knowledge, if you only have the conversational knowledge or some domain knowledge, maybe the banking world or some insurance world or whatever, without the stats knowledge, I don't think you're going to be a very effective data scientist. I personally wouldn't want to work with you. So that's where it's like the crux of the problem. You have to do that at the very least, and then these other skills, which are maybe more important later down your career as you become more senior, then those are great. But without the fundamental, without that strong foundation, I don't think you'll be a successful data scientist.
One of the things I've heard, and I want to actually try and see and test how this plays into a conversation now. So one of the questions I keep on asking other people is what's like the difference between a machine learning engineer and a data scientist?
Yeah.
And some of the things that has come up as well was, and this is now not even on camera as well, it's something that I've had conversations with customers and clients, and some of the stuff that came up was, well, you know, as a data scientist, they follow a lot more of a creative exploratory process or a research-driven process, and they can essentially get I don't know what distract is the right word, but they can. But there's so much to.
You go down rabbit holes. You spend 100 hours, and 90 hours was sort of useless, and 10 hours got all the results and value you needed.
Do you agree with that, or do you disagree?
Totally.
With that
I think that's the fundamental difference between sciences and engineering. Engineering, I think you have sort of strict and specific requirements. You go to your customer, you figure out what they need. Maybe there's a bit of skill and nuance into turning a customer's requirements into technical requirements. But once you have your technical requirements, you go ahead and build that. You go and execute. And if you're an experienced engineering team, you have the skills on board to go and execute that. Science is not always like that. It's a lot more researchy. It's a lot more trial and error, iterative. You 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 have a hypothesis. We think this might work. We explore that. We look back. Does this solve our problem? Yes, no. Maybe it doesn't. Maybe we learn some things and we take some other avenues based off of that original exploratory work, and then we try something else. It's very iterative. Sometimes it's very hard to say before you start this journey how long it's going to take to solve, whether it is solvable. And so that is a very big difference between a data scientist and a machine learning engineer, even though they have this overlap of machine
Similar
learning,
skills,
modeling.
yeah,
Yes, yes.
at the end of the day. I love that because, and for me, what I spoke about in previous ones as well is there could be value in both. There's value in the engineering component.
Yes.
Listen, we have a problem, we need a solution.
Yes.
What is the best solution to actually solve this problem that you know of, that we can implement, that is a high
Yes.
chance of success, given give or take some variables within the organization, the context
Yes.
itself. Like there's a high chance of success. And then there is, okay, we've got a problem, but there's not an existing solution that's an obvious solution. We've got a set of data sets that might work, might not work. So then in terms of the exploration, learning and understanding gained from applying data science, if one can be
Yeah.
crude to say it as
Yeah.
such, means that that is valuable in the sense that you've now understood the space, you've understood
Yes.
the problem, you've understood the data sets that's available, and then you can narrow it down, like you said, maybe that
Yes.
last 10% of, okay, well, we know this, we know all these areas don't work, we know
Yes.
that this is our general focus or area moving forward in terms of solving this problem.
Yes.
Now we can move ahead with that.
I think one of the challenges for data science in industry, in the business world, is that you need to do the 90 hours of wasted time that didn't deliver value to get to the 10 hours that does deliver value. All of that trying and trial and error and iteration and exploration maybe didn't result in a product that immediately gives value to the business. But without that understanding and knowledge building around this domain, this problem, this data set, you're not going to get to the point where you can then understand, okay, actually, we know this doesn't work, that doesn't work, but we know with this, we understood this kind of mechanism, this kind of sort of artifact about the problem, and we can bring that together with this little bit of understanding that we got here, and then we can build something useful, some valuable product. And that's just part of the journey. You need to do that. And so it's difficult to sell just the data science. And I think this is where the engineering part is really, really cool and really beautiful. It's that there's a lot more certainty to engineering problems. So I studied engineering at university, and the one thing we always learned was, as far as possible, get off-the-shelf solutions. If you're going to build some complex system, use existing technologies, tools, products to build your complex solution. Your complex solution is a system of subsystems. As many of those subsystems are already solved out there, go use that solution and then put that together into something that works and delivers value, right? That's sort of what the MLE does, right? They go to GCP, they go to AWS, they go to Azure, they use SageMaker, they use AWS EMR notebooks and clusters and whatever. It's all there, it all works. You can use that to stitch together a system that solves a problem in the banking space, in the insurance space, in the social media space, whatever. But when there isn't an off-the-shelf solution, it becomes a science problem. And this is now where you need to get more creative, more exploratory, and that's when you need the data scientists to come in and do that type of work. And I think it's typically very different people who have those skill sets. An engineer is someone, he wants to put in some amount of time and build something useful that gets used by people, by the business, that creates value. A data scientist could go a long time and many projects without delivering something that is a big money maker, a big value adder, and they still have to find joy and satisfaction in that process, which is maybe not everybody. Sometimes I like to be in both realms, because I love like going down rabbit holes of a problem and learning about the domain and maybe learning new techniques that I try in this domain. But sometimes it's also very frustrating not delivering value. So then it's nice to also do something in engineering work where you you spin up a database, you spin up a cluster, you crunch some numbers, you deliver value. It's much more tangible.
Yes,
But yeah,
if a result
yes,
has a result at the end of the
exactly,
of the path.
exactly.